Welcome back, everyone. Hope everyone has been staying safe out there. I know it's been a very, very long time, but just work, hectic, life, and time is just flying. So let's get into it. This week's video, I am test fitting the engine, and you're going to see an engine dyno, and you're going to see how much power this engine makes. Now, a huge factor that determines hood clearance is the intake manifold. Now, the intake manifold, if I'm going to have this dynoed, I want everything to stick, meaning the tune has to be sticking to all the parts that they're tuning with. So if the intake manifold is too large and I have it dynoed, and then I go in later on at a later date after it's dynoed and realize, oh, my intake manifold's too tall to have proper stock hood clearance, I'm going to have to get a smaller intake manifold, and that could change the whole tune of what they did on the dyno. And yeah, I could know what power it makes, and it will probably make slightly less power if I have to go decrease in intake, but also any carburetor adjustments and all that will be kind of thrown off from the actual change of just an intake manifold. So that's why I'm doing this now, putting it in, checking the clearance, and then going to take it all out and then go to the dyno after that I know that I have proper hood clearance. Now this thing was actually kind of a pain to put in because it had all new motor mounts and everything, and it was very hard to, which is kind of myself working to try to get the volts lined up here, but eventually got it all lined up and in, and then I'm able to finally put the hood on to see. So late last night, ended up getting this all in, temporarily put the engine mount bolts in, just the old ones. I am ordering new ones, so it'll all be fresh because I am pulling this out again. This is just a test fit to make sure that this new intake, when I take this old one off, fits underneath the hood and has clearance. So that way I will have a solid tune when I go to the engine machine or the engine dyno and won't have to mess with it again. So if it's too big, I'm going to go down to the Edelbrock EPS manifold, which is I think like 0.4, half an inch shorter, something like that. And that should give plenty of clearance and be similar to this. This is a single plane intake. That's why I'm not using this one. And I want a dual plane at least for that. And it's an Edelbrock Torquer 2, I think. So it's not as good as the newer styles today with the dual planes with the same company. So let's put some hood hinges on right now. And then I'm gonna try to find, my dad just had hernia surgery. So I don't know if he's gonna be able to lift because this hood is super heavy for this car. So I might have to find a couple other people to help me put this on, but we'll see what it's like with just Leanne, him and I. He just had surgery about a week ago and shouldn't be lifting anything. Back end of this is held up by a jack with a big foam block underneath the oil pan. Paint hardened up real nice, so everything should be good and not marked. I don't know if I mentioned this already, but before anyone mentions why did you paint the engine, why didn't you test fit all this at one time, I'm kind of fighting against the weather. I'm doing this all outside. I don't have a controlled environment to paint in, so I wanted to get this done before the humidity really kicks in, as well as be able to get this on the engine dyno in the near future. So I just decided to paint this, and I'm just really careful with the block right now. Tape everything off. Everything was all assembled on the bottom end. That's why I didn't take off the oil pan and do everything separate that way. So that's the reason for that, and just kind of have a time crunch and trying to deal with the weather with paint. Here's the set of lifters that I got with the cam. They are the roller lifters because I'm doing a retrofit hydraulic roller cam. So I'm gonna dip these in oil real quick. I'm not pumping them up, just dipping them in oil, and then gonna drop them down into cylinder number 1, and then we're gonna start taking our measurements. So these 2-piece guide plates are kind of new to me. What they want you to do apparently is you have to put the letters facing down on these guide plates, according to this right here. So, which doesn't really make sense. If you didn't read the directions, I would assume you put them up because they have a left and a right. So I'm going to do that, and then I'm going to flip them around this way and put them in like the directions say. Doesn't really make sense to me, but whatever. I'll do it like that and see how it comes out. I'm just eyeballing it right now, seeing that there's enough space on each side of the guide plates. And the push rod. So it looks about good right there. These will be more permanently set up later, so it's not the end of the world if it's not correct right now. But I do want to have these torqued down the right way because they might change the height, potentially, of the rocker arm. And I'm going to need a deeper socket. Have to start doing the geometry of the push rods, so you have to determine the push rod length. And the reason you do this is just due to the fact that I have different heads, different head gasket, different lifters, all determine different lengths of the push rod. If you have too long of a push rod, you don't want to bend anything, obviously, or if you have too short of a push rod, it might not even fully open what needs to be open valve-wise. So, I have to make sure that we're on the base circle of the cam. I'm using this push rod length checker by Comp Cams. It is the 6.8 to 7.8 inch checker. So this is typical for small blocks. So you pick this, and then one of these range values are going to have what you need. It is 0.050 inches per turn. So every time you line that line up there and turn it around, that is 0.050 inches. So you can count the numbers of turns and then add it to the 6.8, which is your starting length for this. So anyway, plop that down in there. Remember, we're on the base circle of the cam right now, exhaust side, so we're doing the exhaust lift of 0.530, did the calculation, and I just remember the 5.3 turns is what I'm looking for on this. Now, if you guys would like to learn exactly how to do this, I'm going to link a video, I think it's called Straub Industries maybe, down in the description box below on how to determine push rod length. You first determine which, the geometry of the actual rocker arm, and then the push rod length follows that. So if you guys are curious how to do this, look at my description below, and there will be a video there to explain it way better than I can ever do for you guys. So I determined the push rod length to be about, I think it was like 7.2. And when I was turning the engine over, I got that feeling that your stomach just drops when something goes wrong. And I heard something rubbing on the back of the timing chain cover when I was making sure the geometry was set up by the marker on the valve tip. And something was rubbing, and it ended up being the counterweight on the harmonic balancer. To make a very long story short, Skip White ended up sending me the wrong balancer. These guys were the ones that did all the balancing and sent me the rotating assembly. It's not the machine shop that I have local to my house. It's the guys that sent me the 383 stroker assembly. So it's off to the machine shop, and they were the ones that corrected the issue and sent me up with a new balancer and rebalanced everything. So very, very annoying, but we just have to keep pushing forward. So thank you again, CJ Rombold Engine Builders, for correcting this major issue. And this brings us to finally the engine dyno. So we're about to see how much power this thing makes. They already broke it in for me, called me up, and we're ready to see what it's going to put down on the engine dyno.
Nice little small block.
Yeah, not too bad.